Hello everyone. Today we're going to see another topic called JK flip-flop master slave configuration. Previous topic we have seen JK flip-flop which is having an issue of race around condition. In that finally we found that to solve the race around condition there are three solutions. One of which solution is master slave configuration. So today we're going to see that master slave configuration. So this is our JK flip-flop with its truth table. So we know that this is our JK flip-flop and we are truth table also we are already familiar with that. So next, so this was yesterday. This was last topic we have seen. So in the last topic we found that if master slave is applied, a race around condition will not occur. So this is what our previous topic. So now we are going to see the master slave connection. So master slave connection is nothing but we will be having two flip flops connected in cascade manner. One flip flop will act as a master, another flip flop will act as a slave. So here you can see, so this is one flip flop. So the output of this flip flop is given to next flip flop. Okay, so you can see this is the output of one first flip flop that has been given as an input to the next flip flop. Same as here also. This is Q and this is Q bar for the first flip flop. Same, this is the second flip flop. So from the second flip flop, we have taken the output and given as an input to the J J, which is JK configuration. So feedback has been taken from the slave output and given as an input. Same as Q also, you can see here. So one more point, one more connection what we have having here was clock pulse. So clock pulse, one clock pulse is given to first flip flop and another one we are having it as an inverter, then it has been given to a next flip flop. So what happens means if this clock pulse is 1, okay, if this is 1 condition, this becomes 0. So when this is 1, this flip flop will be active and this flip flop will be inactive. So that is our important motive. Okay, so this is master flip flop and this is slave flip flop. When the clock is 0, suppose when the clock is 0, what happens, this master will become inactive but this slave will become active. So this is the uh, working principle of master slave. So and how this is going to uh, solve the issue of race around. So what will happen? So race around condition will come when all the inputs are 1. For example, J, K and clock. All three inputs are 1 means race around condition will come into picture. So here what is happening, if J, K and clock is also 1, this master will be active. So we are not taking this master's output as a feedback input. So it has been given to an input to the slave, right? So when this is 1, this slave will be inactive. So this output is nothing but a memory output. When this is 1, this will be active. That means master will be active and slave will be inactive. In that case, this will act as a memory and this QM is nothing but a output of master. So output of master will be 1. Okay, so high, so this becomes 1, this becomes memory condition. Okay, so whenever the clock becomes 0, whenever the clock becomes 0, what will happen, the output of this becomes 1, that means master becomes inactive. So when master becomes inactive, that means clock is 0 means as per our truth table this QM will be acting as a memory. When this is 1, what will happen, according to this inputs it will be reacting. Okay, so this will be maintaining this until this becomes, for example previously it is 1, if this activates means the output becomes what, it becomes 0. Okay, toggling effect will come into picture. So this is the general operation. I'm going to show you how it is working. Okay, so assume this is our circuit. Okay, so previously what we have seen, that circuit is given here. I'm going to simulate and show you what is happening here. Okay, and with the graph also I'm going to show you. Okay, so graph, because it will be useful for finding out how according to the clock pulse how it is working. Okay, so what I'm doing was I'm giving input 1. This is also 1. Okay. Now I'm giving clock is 1. So what happens you see? So this becomes 0. Okay. That means it is toggling. Okay. But you can see the state diagram also. When clock is high, so Q becomes high because it is maintained, because this is inactive, it is maintaining the memory state. Previously it was 1, that's why it is maintaining the memory state. But QM becomes 0. The reason previously it was 1, now it is toggling to 0. Okay. So now what I am doing was I am changing the clock to 0. So now what happens, we will see. When this is 0, what should happen? So this entire master will be inactive, so it maintains the previous state. What happens now when this is 0? Okay, when this is active, it will be toggling here. Okay, previously it was 1 and it is becoming 0 here. This is step by step I am showing, that's why it's taking time. Okay, now that's all. So now what is happening? Now this is active and this is inactive. Likewise it goes on. When I again put the clock into high position, what happens? So it is toggling, but still it is in, that means slave is in inactive only. So when I give 0, now slave becomes active. Okay, so it toggles. Okay, this is what happens inside the master slave configuration. So I will show you in timing diagram analysis also. So when all are low, that means clock is also low, means QM also low, Q also low, assuming that previous state is 0 0. Okay. So now when clock becomes high, QM becomes high. This is a master output. Okay. But Q still maintains, that means Q is the slave output. So Q still maintains the low condition only. Okay. Whenever the clock is becoming 0, now Q toggles. Okay. In other words, it is taking the input of master, it is taking the output of master and producing that output. Again if it is 1, master becomes low, but slave still maintains, because whenever there is a clock is 0, then only the slave starts toggling or slave starts to produce the output, because when clock is 0, slave will be active and slave will be active and master will be inactive. Likewise, it goes on. So this is how master slave configuration works. Thank you.